I'm just going to um, begin with here, really the little collection of items that really link across algebra that, of course, is so important in teaching, seeing as mathematics and what many people, whether they know it or not, think about as as being the mathematics that you get introduced to in school. So again, going right back to a early period, um, there we look at what really is a basis of how the introduction to algebra has this area of finding a missing amount, which is obviously written as the x now. But in this occasion, in the very famous Arms Papyrus of 1550 BCE, is a listing of such problems that were not solved by algebra. We do now, but they're very much the same problems as you see at the end of the explanation of the first six problems on the document. That there's one page all shown here, was how to divide various numbers of loaves of bread between 10 men. One of these typical ones: if you've got so many of this, how many of this do you need? And these were set, and so if you like, could be a sort of a proto algebra, but had nothing like the look of an argument that is now seen it. But the type nature of the problem goes way back as far as you could really possibly investigate. Moving on to much later is to an interesting origin of the actual word algebra. And there's a discussion I was in, we were talking about how this is almost a geography as well as a history of mathematics as being worldwide. So the origins of this word, the date around 825, is in the work of Al-Khwarizmi, who is seen really as inventing algebra, and given in this is, of course, the title was in Arabic, and that here you see in part of that translation the compendious book on calculation by completion and balancing, completion similar to completing the square, is Al-Jabra, and it's taken from that that became what we now have as algebra and took the name of the whole topic. And in fact, Al-Khwarizmi's name in itself, in fact, is seen as being the origin of the word algorithm, which is so important in discussing of all sorts of things that are mathematics. So we here have this book there, and again, it did not look like the algebra that we have now. That if you look at the examples of from Al-Khwarizmi's work, is it is not symbolic in any way. But you move on. So so Al-Khwarizmi is working in really in North Africa, and so there was some time before the knowledge that he was putting forward actually came into Western Europe, and that was around the middle of the 12th century. And here again we see one of these areas where you can link across the history itself, so that you have Al-Khwarizmi from the 9th century, and here there was a number of translations around. I've chosen to refer to this one in the 12th century by Robert of Chester, who then did a translation from the Arabic into Latin. And you then have later productions of that, as this example I've got here, of one in the 20th century, of producing that and producing other modern language versions of it, and making that ancient version of the algebra more well known, of the history, as it were, continuing to renew itself, and the form of algebra beginning to be something that comes in. We don't have it beginning to look anything like the algebra we have now and teach in our classes until the 16th century, and where the idea of beginning to use letters for numbers to represent it, one of the earliest versions is by this French mathematician Viet, the end of the. We're still in a period here where mathematicians and scientists, like astronomers, are not professions and are difficult to name. So in his case, he did this out of a sort of almost as a hobby, and had, as it said, that he used letters. The use of the beginning and end of the alphabet, that the unknowns was X and Y, in fact, came a little later from Descartes, and that his version was not the one that continued to how we use it now. From that form of later on, as the beginnings alongside, as we saw the earlier set of things of modern mathematics developing in the 19th century, we have George Boole's work on algebraic logic, which gave its name to Boolean algebra, similar to what George Boole himself was working on, but in fact, in the end, not identical. But we move on. But Boole's book of an investigation of laws of thought that are founded in mathematical theories of logic and probabilities was this idea of moving algebra into expressions of logical processes, which developed into whole new fields of mathematics of the 19th and into the 20th century. Boole being active in the middle of the 19th century in Ireland. So that's my sort of little trip through the history of key parts of the history in algebra. And I thought it was good to collect those together. And now that we look again at some further reasons that we might use the history of mathematics in our teaching. So there's a further 3 suggestions of how it might be used, which I thought would be useful for people to pick up again and discuss before we come back together again to sort of final sort of discussion.
Great. Yeah. So I've created new rooms just because that's what the technology did. And you'll use the same link and the slides are still there up top. And feel free to add a comment under part 2 with these themes for discussion. We'll take about 5 to 7 minutes, then we'll come and wrap up together.